In this video, we are going to see how we are using RAG in our Agentic AI applications, and we can see how to create the modular coding using a logger and exceptional handler. In the first video, you all maybe see the the structure how we created to create for modular coding. This is the applications we are developing to analyze the document. In this applications, we see in the last video about the structuring of the project and use cases of the project and how we modular the coding. So now we are just doing the lab work to see how RAG is working, then how we can do modular coding using a logger and exceptional handling. So first we will see about the LLM and how it's connect with the RAG. RAG means we all know about that retrieval augmentation generation. So initially how it will work, we all come to know the RAG architect. For example, how the RAG is working. This is the database. Database means vector database. Before we use this to retrieve the data, we need to chunk the data. For example, we pass the PDF, we will chunk the data into smaller parts. After that, we will embedding means it will convert vector embedding. That means you convert the data into the 0 and 1 format, then it will push into the vector database. After injection, then we have the screen to develop using Agentic AI or any template, any HTML format. Then the user will enter the prompt. When the user enter the prompt, it will embedded, and after embedding it will go to semantic search. Semantic search means without keyword search it will go and search the related sentence based on the embedding format. Okay, after the semantic search it will retrieve the data. For example, when you do the semantic search, it will bring initially 10 lines. Then we need to get the exact value. For that, again we use rank result. After the rank result, we get the retrieved result. Then this will again go to the LLM. Then it will when you go to the LLM, the based on the query and prompt and context, the result it will generate to the user in proper format. So before the user requested the required information to the vector database, the data will be chunk and embedding into the embedded tokenized into the vector database. From there, we the user will retrieve and get the data. So you got right. So this is the RAG, retrieval augment generation. So this is the way. Then it will format the injection, chunking, embedding, vector DB. Then when user raise the questions, it will go to the semantic search, the ranking, LLM, and generation the data. So like this format, the data will be generated. So we know the retrieval augment generation. The retrieve how it will work. The same what I said from the vector database. It will the query also embedding into the vector database. Then do the semantic search, retrieve the data based on the ranking. It will give the filter data. Again the same the once retrieved, it will go to the LLM with query, filter information, and prompt. Then it will generate the data based on the format what we need. So this is the format with the RAG will be work. Then we will see the hands-on lab. So here we can see here in this a code, initially we will use the grok because it's available free. So we will install langchain, import chat grok. After that we will install the doc environment because we will get the required key regarding the grok or gemini to our this platform. Then it will load. After that we will get the model chat grok. From the chat grok we will get the model, like if we go here, grog model. When we go there it will allow us to, and if you go there you can see all the related once you're logging it will show all the related models here. Then we can get from there, then it will run the model. So we can this is like another model like DeepSeek. Okay, we can from the grok we can do everything. Then we will use the invoke key to speak with this LLM model. Okay, what is the capital of France? So initially to bring, if we need to get only the content, it will we add dot content, so it bring the um, result. So France is the country in Western Europe, and capital is a well-known city like a Paris. So like this, then we create this normal based on the prompt we are getting the data. So here we are using Google generating AI embedding. For to embedding the data we will use the generative, one of the best model to embed the data. Then we'll pass the model embedding JI 001. Then it will embed the data. So then now it's add the embedded model, right? After run, when you add the date prompt into this embedded model, it will bring the data as zero, the numerical, right? This is the one I said, embedding data. Then here what we discuss, what we see in the form, the rag concept we can see from here. Initially it will we will use Py PDF loader to load the data into the vector database. Okay, we will load the Py PDF loader. Then we need to chunk, as we discussed in the screen, we need to chunk the data. For chunking we will use regressive chapter character text splitter. We will run this. After that we will run the OS, then run this one. It will get the path of the where we are stand now. Then we what the data available in the node data, we have the sample PDF I added here. So it will call the sample PDF. Then by PDF folder it will get the PDF file. Then it will load the data. It will take some time because of the it's nearly 70 pages I think. Then we will check the file's length 77. So we need to experience on chunking based on the data availability. If it's big file we will split the data into small chunk we can do. So regressive character text splitter. So here we are going to chunk the data. We will chunk the data as 500 words. Then in between the chunk we add the chunk overlap as 115 words. Chunk means you all very familiar maybe. The between the chunk it will do the overlap for continue the data continuation. Okay, then length. Okay, after that we will split the document. When they split the, when we pass the document here, when then we split the document. After split the document using text filter, this one, the chunk file. Then we will count after chunk the PDF data, it will come as 765 part. Then this is the first position, this is the data available as first chunk. Then we can see the metadata for every chunk. So this is the file, the creator, then all the information. This total page is 77 pages. So this is the first file, okay. So then page is 0, page replace 1. This is the first chunk, and the position is 0, okay. Yes, it will be like this. Then we will check for the 100th one. It will show the total page is 77. Then page is label is 11, and the position is 10 is like a array format, okay, like this. So we can see raw data, metadata here. Then what we will do, we split the data, we loaded everything, we meet see the metadata everything, even the page content we can see here. So we will create the vector store to load the data into the FICE vector database. Here when you come to the vector database, here there's a different type of we can store the data. One is in the RAM, vector data in RAM, vector database in the drive, vector database in the cloud. So files is available for hard disk, and RAM. So we will use files to load the data. Then this one. Then we will pass this content in for embedding the document as in the embedded model. So it's running now. Running. Then how much length after embedding? 768. Okay. Then the data is embedding model, the documents it will store in the embedded vector database. So we all know the token is word retrieving chunk that it will display the data, the chunk file, then load into the vector database. After that we will send some informations, llama fine tuning benchmark experience. You go as a similar search and bring the related data. See, initial by default it will bring the 4 line of data. Then we cannot see the content directly. Then retrieval document pay position 0 to bring the first file only. Then bring the page content, like this we can see. After that we need to bring 10 values based on when you run it will bring to totally 10 lines, 1 2 3 4 5 6 7 8 and 10, like that, okay. After if we need to bring only means it will bring only one data. So we know now how to push the data into the vector database. From the vector database how we can retrieve the data. So this is the this way we can use the RAG. After this lab experiment we will do the full fledged project on the next video. So I will push this data into the GitHub. You can see the refer the code in the GitHub. Still I am also learning through thanks to Krish and Sunny to explain this. So we add this one, the same format. So here now we added now generally. Now we need to put the say what I said before pushing the LLM. We need to add prompt. With the prompt context means what we are get from the vertex database. Then what the questions the user raise prompt questions. So it will answer the question based on the context provided below. In the context does not contain sufficient information. Response with I don't have enough information about this. So the computer system will follow the same instructions. So I run the prompt. After that I run the prompt template. So prompt template means this is the template we need to follow. The prompt template, the template is prompt template, this one. Then input variables, so context and questions. What the context we get from the vertex database, it will push here, and the questions we will get from the user. Okay, after then run now. Then we will run. This is the prompt we get now. Then store output post. So in which format we need to get the output. This also we will get. So this is the functions helper function to get the content page content only. This one, okay. Then this is the runnable parse through for to get the current message what the user enter. This will enter. Okay, this is the rag chain to run the form data properly and return the result as proper way. So we will use the pipe function in the rag. So this is the context retrieval what they get from the vector database. Then it will get in the proper format documents like page content only. After that, the questions what we are passing, this information will first it will execute this, then it will go to the prompt. When you go to the prompt, it will go with this value based on the parameter. After that, it will go to the LLM. After go to the LLM, then based on the result, it will set the send the string output faster. So okay, after we will run this. After run this, it invoke the the prompt. Yeah, see, we ask this request, tell me about the llama fine tuning benchmark experience, so it added here. Okay, it like that it will send the result. Okay, so like this we can use a rag in our applications. So this is the main part to give the data in structure format. So initially to pass the retrieval and this questions, then you go to the prompt, then you go to the LLM, then you give the proper result to the user. Okay, thank you. Stay tuned us. We will see in another video. Thank you.